Happy May 14th, everybody. Mr. Rohde here. Again, I know this week has probably been our busiest week with longer videos and a little bit tougher stuff. But today we're looking at just one lesson, 34.5. I've broken it up into two parts, hopefully two shorter videos to help with this. And things should be a little bit lighter again next Tuesday. And then just wrapping up with our test on graphing next Thursday. Again, check Schoology for all the updates you need. And after this video, you should be able to do the first homework part, and then we'll look at a little bit more complicated problems in the second video. As a reminder, here's all our goals from this particular fluency test and unit. Down here is our goal for today, graphing phase shifts, which are also known as horizontal shifts, which we've done before, and vertical shifts. So we've done these to other functions, but what do they look like with trig functions? So really bringing all of our graphing stuff together. We've done a lot of shifting in the past, so we can build off of that for this unit. Okay, so on page 533 of your book, we're in lesson 34.5. Here's our goals again. And most of this starts off with just exploring with our graphing calculators. We've gone through how to graph those in the past, so I'll show you the Desmos graph, but I highly recommend that you do this to start, graph these three functions to see how those numbers impact it. One big thing I'll point out is our book doesn't always put in parentheses. This is sine of x. This plus 3 is outside of the trig function. This minus 2 is outside of the trig function. We'll talk about what the number does inside the trig function on our next page. But for right now, try graphing those three functions in Desmos, see the comparison, and then we'll look at cosine and tangent as well. Okay, here's the graph. Hopefully no big surprise here. If we just add 3 to a function, it shifts it up 3 units. So instead of starting at 0, 0, it started at 0, 3 in the red there. And then for sine of x minus 2, it moved down 2 units. Instead of starting at 0, 0, everything was shifted down 2 units. Let's see if the same thing happens with our cosine graph. Again, big note here, watch the parentheses. This really means cosine of x, cosines of x, and then plus 4 on the outside, cosine of x, and then minus 1 on the outside. Again, we'll look at adding or subtracting on the inside next, but try graphing these three, and then we'll look at those. Let's see if the same impact happens. So again, as you see, we got shifted up 4 units with the plus 4. So instead of being at 0, 1 for our start, we got moved up to 0, 5, because 1 plus 4 is 5 for that maximum value. And for cosine of x minus 1, instead of being at 0, 1, we actually start at 0, 0 and go down to -1 and then down to -2. So everything got shifted from that original parent function, that original black function got shifted down 1 in the blue. All right, take a look at the bottom three, the tangent x plus 3. Again, careful with those parentheses so that all of the numbers are outside of the trig functions, and see if the same up and down shifts happen. Okay, if you graphed those yourself on your calculator, you should have gotten very similar results here. To be expected, the red one starts normally was at 0, 0, but it got shifted up to 0, 3 for kind of that starting point if we're thinking about the generic shapes we've been dealing with. And then for x minus 2, got shifted down to 0, -2. Everything got shifted down 2 or up 3, depending on that. So again, up or down shifts pretty much behaving how we've seen before. What about left-right shifts? Let's take a look at those next. So now we're going to look at left-right shifts. We're going to be looking at adding or subtracting with inside the sine and cosine functions. Real key here, notice the parentheses work. And then 2, also notice you're usually adding or subtracting by some type of pi value, because again, our x-axis is generally in radians. Now, if we were in degrees or something else, we could shift left to right by integer values like 1, 2, 3, or 4. But honestly, it's a little bit easier to shift left to right, pi's over 4s, pi's over 2, since that's what we're used to for our period and all kinds of different stuff. So go ahead and try graphing these three functions on your Desmos graphing calculator or your TI-84 just to see which way moves left and right. And from there, we'll look at cosine and tangent next. So try that, and I'll show you the answer here in a moment. So as we take a look at the results here, we can see in red, comparing to the black function, it actually got moved back or to the left. So if I'm adding pi over 4, that's actually going to be to the left, which matches that horizontal idea being opposite we've seen in many of our other functions with shifts. And here in blue, minus pi over 2 is actually moving it to the right. Right? And so it was here at 0, 0, it got moved to the right here to start at pi over 2. So the whole thing got started, shifted to the right. And again, because it's periodic, it's going to keep repeating over and over, both to the right and the left. So there's a lot of different ways you could look at this, but essentially that 0, 0 point of going up to the maximum, that all got shifted to the right pi over 2. So plus is to the left, minus is to the right, very much like our horizontal shifts being opposite in prior ones. Let's see if the pattern holds up in cosine and tangent. And here we go. It looks like we were confirmed. The red one moved left pi over 3. Okay, normally we start at the max of 0, 1, but that was moved to the left. Pi over 3 would be that marker. And then in blue, this was moved to the right, our general shape of starting at 0, 1, and then going down and then back up. So starting at our max, ending at our max. Normally that's 0 and goes to 2 pi. Here it was shifted to the right 2 pi over 3. So our max actually is at 2 pi over 3, comma 1. And then we'll go 2 pi forward from that. So 2 pi plus 2 pi over 3. I believe that's close to 8 pi over 3 would be where it ends, or 2 pi later, based on our period. So let's take a look at tangent, and then we'll try graphing some of these by hand, now that we've noticed the patterns. And just like we expected, if we look at the black as the original, the red plus pi over 2 is getting moved to the left to get to the red. Plus pi over 2, meanwhile, x minus pi over 4 is moving to the right, pi over 4. For that blue one. So again, just kind of shifting our origin up, down, left, right, shifting our starting points. Let's look at doing a couple of these together by hand. So one key point here is that they actually in trig call this a phase shift. So instead of calling it a horizontal or left-right shift, they actually call it a phase shift. So we'll use that from time to time. But the idea is we're going to think about what the general shape of our starting functions are and how to move them. On this page, on page 535, they have two examples, example A and B, where they walk through how to do that in the books method, and then I'll show you a couple examples working through it with my method here. So feel free to pause and read through either one of example A and example B to see how the book does it, and I'm going to talk you through some here next. Okay, so how do we apply these left, right, and up and down shifts? So as I look at this, I'm going to say, what is my period? What is my amplitude? All those kind of different things. So for sine, it was 2 pi. There's no number in front, so my amplitude is 1. So going up and down 1 from my new kind of shifted axes. And so then this is to the left, pi over 3, and then up 2 for these shifts here. So when I go to mark my axes, I definitely need to go, my up, I need to go up to at least 3. And so I'll go by 1, 2, 3, 4, and then -1, -2, -3. And then for my x-axis, I'm moving left pi over 3. So I definitely, my period's 2 pi, so definitely want to go by pi over 4s, but because of the pi over 3s, I probably want to go by pi over 6s as my tick marks on that. So 1, 2, 3, 4, 5, 6. So this will be -pi over 6, -pi over 3. And then going forward, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, and I'll keep going, 1, 2, 3, 4, 5, 6, that would be 2 pi. So I know I'm going to be able to contain everything. My new shifted axes, left pi over 3 and up 2. So my new origin is going to kind of be here, where I'm going to base my graph off of. And what does sine look like? If I remember our basic notes, it starts at that 0, 0 point, goes up, down, and at the end. So this is my full period. So where is this new 0, 0 point? Well, in blue, that's going to be at this new shifted origin, right? So if I want to label it, -pi over 3, comma 2. And then I'm going to be at that same midline all the way at the end of my period. So what is 2 pi forward from that? Well, it's really 2 pi minus pi over 3, so that's 2 blocks. So 2 pi minus 2 blocks. That's where I'm going to be at the end again. So really that's, if I want to think about it over 6s, that's 12 pi over 6 minus really 2 pi over 6. So that's going to be 10 pi over 6, or 5 pi over 3. I'm going to be at 2 again. Right in the middle of that, so number of blocks. So 2, 4, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 12. So 6 blocks, 1, 2, 3, 4, 5, 6. This would be exactly in the middle for my sine graph. So again, as I go to, so it's 2 pi over 3, comma 2. Right in the middle of those two is my maximum point. So my amplitude's 1, so 1 up from where I'm at, so that's 3 blocks. So that's going to be at pi over 6, comma, positive 3. This is where labeling your x-axis is really important. And if I go down in amplitude, this is going to be at 7 pi over 6, comma, positive 1. And then I can go ahead and graph this function as well. And I know that it's going to repeat. If you want to throw the original gray sine function again, you can do that 0, pi, 2 pi, pi over 2, it's at 1, pi over 2, it's at negative 1. And there you go. There is sine shifted left pi over 3 and up 2. Looks pretty similar. Let's take a look at tangent. It's got a little bit different shape. The biggest thing is going back to what is the shape of these things and how can I then adjust my tick marks to be needed. So this has got, again, amplitude equal to 1. Its period for tangent that we learned on Tuesday was that it's pi. And then it is going right pi over 2 and down 1. So again, in tangent, we probably want to be going pi over 4. That's a quarter of our period, so that should be fine. Lines up with all of our nice numbers. So pi over 4, 2, 3, full pi there. 1, 2, 3, 4, 2 pi there. Negative pi over 4, negative pi over 2, and then negative pi. Down 1, so again, I'll just go by ones here. So 1, 2, 3, negative 1, negative 2, negative 3. And if I remember the general shape of tangent, it looked like this. It went through that 0, 0 point, which is now being shifted, and it was a half period to the left for the first asymptote, half period to the right for the next asymptote. So let's think about where this new shifted axes would be here in red. So right pi over 2, down 1. So pi over 2 and down 1 is here. So my new 0, 0 point is here. If I want to kind of think about that. My period is still pi, so pi over 2 to the right is going to be from pi over 2 over to another pi over 2. That's actually going to be here at pi. So here's my first vertical asymptote at x equals pi. Pi over to the left will actually be at 0. And again, I could repeat this over and over again. Halfway between there, I'm going up 1 on the amplitude. Halfway between those to the left, I'm going down 1 on the amplitude. And I've got my shifted tangent graph. And again, in gray, if you wanted to put the original, this one would go through 0, 0, pi over 4, 1, negative pi over 4, negative 1, and it would have an asymptote at pi over 2, actually, and an asymptote at negative pi over 2, but it all got shifted to the right pi over 2, and then down 1. So to start with, we're just keeping the same original period, original amplitude, and shifting our starting point, those kind of shifted axes, shifting them left, right, or up or down based on how much you see. So you should be able to try the first homework assignment for this, just keeping everything relatively the same shape and going from there. And then we're going to look at some more complicated versions in the next video and the second homework assignment.